And then you come to the last, which is the proof load test. Proof load basically is the safety test. Let us say a sample, a mock-up is designed for 2 kPa wind loads. So, what happens is that nowadays we find unexpected levels of activity in winds. The cyclonic pattern is different, the weather patterns are changing, and the wind loads are increasing in certain areas. So, this is a safety test basically, which is to put 1.5 times or 150% of the design load pressure on the curtain wall on the positive and the negative. There are no measurements, it is again a visual just to see if all the elements in the curtain wall are there and the integrity of that entire structure is there physically. So, it is very important to ensure that in a worst come worst scenario, the glass does not fly off or the system does not buckle or the hardware does not give up. So, the proof load is a very critical test to put it on worst come worst scenario, and then if that passes, then you are absolutely sure that whatever happens, this thing is not going to fall down. And then you have the building maintenance unit, BMU. You must have seen people coming down in a building to clean it using a gondola. So, you also have a BMU pull out, because these tall buildings, when the gondola comes down from the roof, because of the winds it starts to sway, and in order to avoid that sway they put in pins every 20 feet, and the wire, the steel wire is actually locked into that BMU pin, so that it does not sway. So, that is exerting certain loads on that pin, and then in turn getting transferred to the curtain wall or the facade. So, what we do is actually physically, the pin is fixed in the sample, and we do a load test on all the 5 directions, left, right, top, bottom and outwards, to ensure that the same amount of load which is actually transferring itself from the gondola, we replicate it by adding certain safety factors to that. So, around 2.5 kilonewton of load is added and pulled in all directions. The pin should not give way, neither should the curtain wall move too much, and it should not be able to, there should not be any damage to the curtain wall. Then we do an impact. An impact analysis is just to simulate, let us say you have the vision panel. If you look at the curtain wall or a facade from inside the building, you have up to the sill level, you may have a opaque structure, I mean a kind of a glass which is not visible, but from here till the false ceiling you will have a vision panel. So, or some of the buildings right from the floor to the top you have vision panel, that the glass is clear glass or reflective glass. So, what happens if somebody walking on the corridor trips and falls on the glass? The impact of the person falling, how much of joules of energy is getting impacted, and whether that glass panel is able to take that load. So, we simulate by adding by dropping a weight which is hanging from the roof, you pull it back and then let it fall, and that creates a certain amount of kilonewtons of impact, and with that impact the glass should not shatter. So, that is a pass fail criteria again. Thermal cyclic test is also becoming very important in a country like India, where in certain areas, say up north in Delhi and UP and all these Punjab, in those areas where the temperature difference during the winters and the high temperatures during the summer is quite very extreme. So, what happens is, because of this the wind, the climatic conditions, there are certain amount of linear expansion and contraction. So, because the curtain wall or a facade has glass, it has aluminum, it has rubber, it has gaskets, it has silicon, and all these things are expanding and contracting because of the temperature. So, we need to create or simulate such kind of conditions. So, what we do is to have a curtain wall sample, and we have an insulated box, or let us say 1.5 floors high or 2 floors high, and this box is the actual outside in a real life situation, and we create an atmospheric condition inside that box, and that is in turn affecting the curtain wall from the outside. So, we come down, chill the box and bring the temperature down to, let us say, 5 degrees or 3 degrees, and then you increase it to 50 degrees, hold it for 6 hours, come back to normal temperature atmospheric, chill it down to 2 degrees, hold it for 6 hours and then come back to normal. Like this you continue over a period of 3 or 4 days, you have 3 cycles or 6 cycles, and then after you do this, you do a repeat of air and water just to check whether with all these expansion and contraction, whether there are any holes which have appeared in the curtain wall, and if so, why, and what is to be done to correct it. Of course, acoustics, you all know, we have huge high-rise buildings on main roads and the noise outside is pretty high, and generally an office or a house needs a certain amount of low audio, sound and noise inside. So, you actually can measure how much of noise is coming through the facade and what can be done to reduce that sound. So, using the right kind of glass, the right kind of system and the gaskets, you can cut down quite drastically the amount of noise that is coming into the building. So, that is also you can simulate it by creating a noise outside, have a sample and measure the noise from the inside. So, acoustic testing is slowly gaining popularity in India. Now, on site, once this off site is done at the lab and everything is passed, the architect and the consultant says, okay, your sample is good to go, start production and then start installations. So, in order to ensure that the same kind of care is taken at the site and to ensure the quality, there are specifications again for checking the water and air at the site. So, for water you have a specific nozzle as per AMA 501.2, and there is a pressure gauge which is a calibrated pressure gauge, and we have a high pressure of water sprayed in a particular pattern through this specified nozzle on the vertical and horizontal grooves. And this is a random sample that will be selected by the architect. Nobody knows which area is going to be tested. It could be any area. So, this testing starts, and then only the vertical, all the grooves are tested, and typical sample is 3 meter by 3 meter, and it takes about an hour and a half to check all the vertical and horizontal joints of that particular sample. And people are standing inside the building and observing it. Obviously, the pass fail criteria is that no water should come inside. And for an air leakage, in order to maintain do the air testing at site, we need to build a small temporary chamber using plywood, very thin plywood, and then have a blower connected there, have a manometer to measure the differential pressure, and have the array of nozzles from outside, just like we do it in the lab, for 15 minutes and check for water if it is a window, and you have a airflow meter in the blower, and that will measure the leak through the sample at the site. So, these two things are again done just to counter check whether it is matching with what has happened when the lab test was completed. This is very essential, especially the water test is very essential for skylights which are used in public spaces, because even a small hole on the top can lead to a lot of leakage in water and cause accidents on people slipping and falling, or damage to property or the interiors of the building. So, on-site water tests are very important to ensure that consistency of delivery at the site can be ensured by the fabricator. Then load tests, basically you have the expansion bolts which are anchored into the concrete, and those are the anchors which are holding the brackets, and the entire facade is mounted onto those brackets. So, there is a lot of load on that particular anchor bolts. So, there are tests to pull out and see whether the tests are able to, the anchor bolts are able to take the load. So, those bolts are tested on even those channels which are cast in channels. Nowadays, people are casting the channels into the concrete, whereas when the concrete is cast, and then the bolts are slid into that channel, and then the bracket is installed on that particular channel. So, we do a pull out test and see whether the channel is able to take that design load, and there is no failure over there. And also the shearing of that, you push the thing on the side and ensure that the bolt does not shear off because of the load, vertical dead load. Now, which are the standards to apply? Now, the most prominent standards in the world now being used by consultants is the American standard, which is the ASTM or AMA, or the Australian New Zealand standard ASNZ, or the British European standard BSEN. Now, which standards are good, which is bad? I would say all of them are equally good, and they have evolved over a period of time based on the requirements and based on the experience that these people had, and they have improved constantly and upgraded constantly. So, in that sense, every test, whichever standards you follow any standard and you get a product which is past those standards, you can be assured that there is going to be, you are getting a good value for that product. Now, advantages in the cyclical test that we explained earlier is that the test pressure is on the entire mock-up. Every square inch of that mock-up has got the uniform pressure which is created in the chamber. Unlike dynamic, where the pressure is high in the periphery, and then as you go away at a distance it drops because it is an open to sky. So, here you have a uniform pressure on the entire sample, and you can go up to much higher pressures to test it, and its gusts, actually the 3 to 5 seconds is almost like a natural low wind frequency, it is being repeated, and it is very effective for mock-ups. It is a very difficult specification, and if the water passes in a cyclic test, it is actually a very good result for the for the designer, and commendable because it is very stringent. Dynamic is, water is wind driven, so it simulates a cyclonic kind of an atmosphere. It creates a turbulence and fluctuating wind which is close to the natural conditions, and it is effective for mock-ups which have sloped roofs and external features and lot of corners, where it is very difficult to have a uniform spray of water in uniform pressure. It will be better to have a dynamic which is covering the end, and you have within wind going through these corners and creating their own turbulence, and that in turn tests how good the sample is in terms of water resistance. So, there are videos which are attached to show you the static water, the dynamic water, the seismic movements, and the structural. You will be able to understand better when you see the pictures. Now, which standards to use? Some of them are lenient in one particular area, but they are very stringent in the next. So, in essence, you pass any standard, it does not matter which standard it is, you will end up with a very structurally sound, a watertight, and a highly efficient, air efficient, energy efficient facade. Now, coming to the mock-up size, what should be the mock-up size? The specification says a minimum of 3 panels width and 2 floor height. So, that is the minimum size that should be tested, and sometimes the consultant also asks for a corner, because the corner is a very critical joint. It is 3 panel width with 2 panels in the corner. So, this becomes the minimum size for a mock-up sample. There are some pictures of mock-up samples just to show you how it will look in the, this is at the laboratory, it is not the real building. The sample is at the lab, this is constructed at the lab to test it, and it is exact replica of what is happening in the site. The same design, the same profiles, the same elements, the same screw, bolt, nut, gaskets, glass which is used in the building, it is going to be tested. So, this is how it will look as a sample. So, for the windows and doors, the largest window in that particular project using the same profile. If you have small windows, big windows, and all of them are using the same profile, the same glass thickness, then test the largest, so that all the smaller windows are automatically passed along with it. So, this is a typical sample of a building with the aluminum composite panel, the window, the external elements, everything fixed. This is the mock-up, for testing as a sample. This is another sample where you have a fixed glazing curtain wall with a window and a aluminum composite panel, and people are standing inside the sample, and there is a water test going on, and they are seeing if there is any leak through the window. And for balustrades and handrails, at least 3 vertical posts, the sample should be having 3 vertical posts, if there are vertical posts. Nowadays, you have a lot of windows, handrails where you just have glass held in the bottom with aluminum clamping system. So, in that you need only the largest aluminum glass panel to be tested, one panel. When there are handrails or balustrades with vertical stainless steel vertical hole, balustrades, and then there is a handrail, then you need to have at least 3 verticals on that sample. So, what are the common failures that we see during the test? Now, typical failures will be water leakage, where you see here water is leaking through the openables, droplets coming in through the joints. So, these are typical fabrication issues which can be addressed either because they have not cut it properly, or sometimes it is a design problem. For example, over here there are probably not enough drain holes on the window shutter on the outside. So, the water is overflowing into the inside of the building. So, water leakages are very dangerous and totally avoidable. If the design is good and the fabrication is good, you can avoid any kind of water coming into the building, because it is very difficult to identify where it is coming in from. For example, you see the small screw which has been put into the aluminum frame. Now, whenever there is a screw to be put, they usually use a silicone on the screw and then tighten it, so that the silicone closes the little holes which are created over there. Here the screw has been put without that silicone, and there is water dripping in through that little hole. So, this is again an example of bad fabrication. And then you have structural failures. Here the entire glass is blown out, it is not able to hold tight. So, the wind loads, this will really happen in the building. If suppose this is a 30-storied or a 50-storied building, can you imagine what will happen if the glass shatters, and even a small piece of 2 square inches of glass falls from a 30 or 40-storied building, it comes down like a bullet, and if it hits somebody on the head, it is going to for sure break his skull. Here you see the aluminum given way because of the structural load, it is not able to take the load. A panel has come out of the mock-up sample. These are all typical failures that we see, and then corrective action needs to be taken to ensure that this does not happen in the real building. Reinforcements are done, the aluminum itself is buckled because of the wind loads, or you have typical situations where the glass panel is delaminated, come out, the composite, the back pan GH tray which is there in this curtain wall has come off, not been anchored. The aluminum is sheared off from the bracket by it just torn out because the thickness of the aluminum is not adequate at the point where it is anchored. The bracket is come out of this whole lock because the whole system is moved out. It is delaminated. Again, here you see the bracket is totally gone, distorted, and the lock which is supposed to be here, hooked in here, it is actually slipped out and come out. So, this is the slab. So, this whole curtain wall has come out by so much. Here the glass is blown out. So, these are all typical structural failures that we see. The pin is sheared for locking pin. So, these are some of the failures that we see, and at the end of the day, any product that we use in our lives, we use it after it has been tested. So, that is how these products become iconic. What is the difference between a successful product, iconic brand, and a cheap one? It is the consistency with which it performs. And how do you achieve that consistency? It is by putting it through a rigorous test, so that under normal conditions it performs beautifully. So, at the end of the day, a facade is like any other product. It is designed to do certain things. and there are clear established parameters. All we need to do is to measure that and see whether the performance of that particular facade is matching the parameters that have been specified, and if it is, then you get a good product.